Good morning, students. Today we will study about formula. This is called the formulae of chemical compounds. Chemical compounds. Formula making of chemical compounds. First, what is chemical formula? Chemical formula. Chemical formula is the symbolic representation. It is symbolic representation of a molecule. Symbolic representation of a molecule. Now in a molecule there are constituting atoms which forms molecule. So we will represent molecule symbolically by representing their constituting atoms in symbols. For example, calcium carbonate. This is a calcium carbon oxygen. Combinedly in as CaCO3 they form calcium carbonate. So the question rises, how we will write chemical formula? Actually, chemical compound is made up of atoms, and in chemical compound there are group of atoms carrying positive or negative charge. The positive charge ions are called cations and negative charged ions are called anions. That is, positively charged ions are called cations, negatively charged ions are called anions. List of few cations I have written here: monovalent, bivalent, trivalent, tetravalent. Mono means single, having single valency. Bivalent means double. Tri means triple. Tetra means 4. So hydrogen, H positive, potassium, sodium, ammonium, cuprous, aurous, mercurous, they are monovalent. Bivalent are given here, trivalent, tetravalent. Pause this video and write all these cations, and I have written few anions here, that is again monovalent, bivalent, trivalent, tetravalent. Write down all these in your copy, and now we will discuss about percentage composition of compound. Percentage composition of a compound. The percentage composition represents the relative mass of each of the constituent elements in 100 parts of it by mass. That is, percentage composition of a compound is the relative mass of each of the constituent elements in 100 parts of it by mass. For example, calcium nitrate. Here the atomic mass of calcium is 40, nitrogen 14, but here 2 nitrogen, so it is 28. 14 2s are 28, plus 1 oxygen atomic mass 16, Here 3 2 ja 6. It is not 3 plus 2 5. It is 3 2 ja 6. 6 oxygen atoms. So it is 16 multiplied by 6. So it will come 40 plus 28 plus 96. It will come 164 U. So percentage, how you will calculate the percentage of calcium? It is mass of calcium divided by molecular mass of calcium nitrate multiplied by 100. So you will calculate this value. Similarly, you will calculate of percentage of nitrogen and percentage of oxygen. Now we will do one numerical. Numerical is how much of copper is obtained from 100 gram of copper sulfate. Question is how much of copper is obtained from 100 gram of copper sulfate. First calculate the molecular mass of copper sulfate. Copper, its atomic mass is 63.5 plus sulfur, it's 32 plus 16 multiplied by 4. It will come 159.5 U. So you can write gram molecular mass of copper sulfate is equals to 159.5 gram. But according to question, we have to calculate how much of copper is obtained from 100 gram of copper. Now, in 159.5 gram of copper sulfate, how much copper is there? 63.5 gram copper is present. So 100 gram in 100 gram of copper sulfate, how much copper will be there? 63.5 divided by 159.5 multiply by 100 and you will tell this value. Another question is on analyzing an impure sample of NaCl, the percentage of chlorine was found to be 45.5. What is the percentage of pure NaCl in the sample? On analyzing an impure sample of NaCl, the percentage of chlorine was found to be 45.5. That is the percentage. What is the percentage of pure NaCl? You have to calculate the percentage of pure NaCl in the sample. Molecular mass of NaCl and sodium 23 plus chlorine 35.5, it will come 58.5. Now percentage of chlorine is 35.5 in 58.5 U, that is molar mass. Okay, so percentage, that is 35.5 divided by 58.5 multiplied by 100, it will come 60.6. Okay, so if we will think that 60.6 parts of NaCl is 100 parts, if chlorine is 60.6 parts and NaCl is equals to 100 parts. Okay, so we given is 45.5% of Cl is found to be present. So 45.5 divided by total chlorine, that is 60.6 multiply by 100. From here we can calculate what is the purity. That is how much pure NaCl is this NaCl. Sorry. So from here you can calculate, it will come approx 75%. It will be the answer. Now we will discuss another topic, empirical and molecular formula. Earlier we studied about chemical formula. Now what is empirical and molecular formula? Actually, empirical formula gives the simple whole number ratio of the atoms of various elements. This gives the simple whole number ratio of the atoms of various elements present in one molecule of the compound. But molecular formula gives the actual ratio of the atoms of the various elements present in one molecule of the compound. For example, you all know about benzene. You studied in class 10th. Benzene was somewhat like this. The formula is C6H6. This is the molecular formula. If I will write in simple whole number ratio, you can write it as CH1:1. It means carbon and hydrogen are present in 1:1. So this is the empirical formula. This is molecular formula. Let us take another example. Acetic acid, that is CH3COOH. This is the molecular formula. You can write how many carbons are here. 2 hydrogen, 4 oxygen, 2. So simple, you can write that carbon, hydrogen, oxygen are present in 1:2:1. This gives, that is, we can write CH2O. This gives the empirical formula. There are some examples in which the empirical and the molecular formula both are same. For example, copper sulfate, ammonia. These are the compounds in which empirical and molecular formula both are same. Now, what is the relationship between empirical and molecular formula? It is, from here you can see, that is, molecular formula is equals to n times of empirical formula. In place of n, it can be 1, 2, 3, 4, 5, so on. That is, how many times empirical formula will repeat itself to give the molecular formula. That is, molecular formula is n times of empirical formula. Now we will do numerical, in which we will find out the empirical formula from the given data as well as the molecular formula. The question is, a compound on analysis was found to contain the following composition: sodium 14.31%, sulfur 9.97%, oxygen 69.50%, hydrogen 6.22%. Calculate the molecular formula of the compound, assuming that the whole of hydrogen in the compound is present as water of crystallization. Now what is the meaning of this line? The whole hydrogen are present as water of crystallization. You have studied about the washing soda, that is Na2CO3 10H2O. Now it contains 10 water molecules. These water molecules are known as water of crystallization, and the meaning of this line, hydrogen in the compound is present as water of crystallization, it means all the hydrogen that will exist in this compound will exist as water of crystallization in this form. So To calculate the empirical formula, to calculate the empirical formula, first write here elements: sodium, sulfur, oxygen, hydrogen. Oxygen, their percentage 14.31 is given in the question. 9.97%. Sulfur, hydrogen is 6.22%, and oxygen is 69.50%. This is the percentage. Atomic mass, we know that sodium has 23, sulfur 32, oxygen, it is not oxygen, hydrogen. Hydrogen is 1, oxygen 16. We will calculate atomic ratio, and to calculate the atomic ratio you will write percentage divided by atomic mass. So it will come 14.31 divided by 23, it will come 0.622, it will come 0.622, and similarly here you will calculate, it will come 0.311, and you will divide 9.97 divided by 32, it will give 0.311. Here it will give 6.22 divided by 1 is equals to 6.22. 69.50 divided by 16, it will give 4.34. From here you will take 1 as a fixed value with respect to which you will calculate simplest ratio. Take smallest one as fixed with respect to which you will calculate the simplest ratio. So to calculate simplest ratio for sodium, it will, this value 0.622 divided by this one 0.311. For sulfur it will come 0.311 divided by 0.311. For hydrogen 6.22 divided by 0.311. For oxygen it will 4.34 divided by 0.311. It will come approx to 120.14, and then you will calculate simplest whole number. Again take as one fixed, and similar to divide by 1, it will come same, it will come same values, that is to 120.14. It means sodium, how many sodiums? 2 sodiums will be present in this formula. So empirical formula you can write sodium 2, sulfur 1, hydrogen 20, oxygen 14. This is the empirical formula. This is empirical formula. From here you can calculate molecular formula. To calculate the molecular formula, how you can calculate molecular formula? Molecular formula is equals to N into empirical formula. First you will calculate molecular mass of, first you will calculate molecular mass which is given, that is 322, that is given. You can also calculate the empirical formula mass. Empirical formula mass, it is 23 multiplied by 2, because we have written the empirical formula Na2SH20O14. So it will come 23 multiplied by 2 plus 32 plus 1 multiplied by 20 plus 16 multiplied by 14. So it will come 322. So from here you can write molecular mass. If you will write this in this form, molecular formula is equals to N into empirical formula, it means some value, when you will multiply with that value, empirical formula and molecular formula, these two will be equal. It means if molecular mass is equals to some n, so molecular mass will be equals to n into empirical mass, that is empirical formula mass. Empirical formula mass is 322 multiplied by n, and molecular mass is 322. So n will come 322 divided by 322 is equals to 1. So the value of n is 1. So molecular formula will be same as that of empirical formula, that is Na2SH20H14. But this is the empirical formula. All hydrogens are present as water of crystallization. It means 14 hydrogen are here. Water of crystallization means water, H2O. Now, sorry, here it is O, oxygen 14. What hydrogen are 20. So 2 is here. So it is 10 H2O. That is 20 hydrogen, 10 oxygen. Now remaining part is Na2S. How many oxygens left? 4. SO4. This is the molecular formula.